I'm Will, and I'd like to show you OrganiseMe, an application designed around the idea of making it easier to keep your jobs organised while working from home. For this project, I was working solo. The inspiration for this application came when I noticed that my partner is using multiple solutions, including a company database application, Microsoft Teams, and Google Calendar, to keep track of work. I wanted to build an application that could be a one-stop solution for tracking all of these things. So let's have a quick tour of the application. When a user first visits the application, they will be given the option to sign in using their Google account. They also have the option to use a toggle to stay signed in. Upon signing in, a new account will be created for the user and they can immediately begin using the application. The first page the user will see is the dashboard page. From here, the user has access to a list of jobs that they have decided to track and an RSS reader that they can use to either keep track of news relevant to their work or just to browse their favourite articles during some downtime. Initially, there won't be any track jobs as we haven't added any jobs yet. By default, every user will have the BBC News feed, but extra feeds can be added. Simply paste the URL of the feed into the input box at the top of the reader and click Add. Once the reader has finished loading the new feed, a new tab will appear in the green bar, which can be clicked to change the active feed. To remove a feed, simply click the Feeds button, locate the feed to be removed, and click Remove. Moving on to the Jobs page, we can see that we have another list. From here, a user can add a job by clicking Add. Provide a job title, a deadline, and some details about the job. There is also an optional client name input for those users working with many different clients. Submit the job and it will immediately appear on your jobs list. If we visit the calendar page, we can see that the deadline for this job is added to the calendar and marked in red. Now that we've added a job, we can navigate to the job page by clicking on the job card. At the top of the job page, we can see all of the information about the job, as well as having two buttons. Clicking Track will add the job to the user's tracked list, and the job can now be accessed easily directly from the dashboard. Click the button again to untrack the job. The job also has a list of subtasks. Again, simply click the Add button to add a task. Provide a title and click Submit. Only the title is required for a task, but for this demonstration I will include a deadline. Let's add a second task, but provide all of the fields. When we provide the two dates, they are both added to the top of the task card. Additionally, if we visit the calendar page again, we can see that the deadlines for the tasks are added to the calendar and marked in blue. If no deadline is provided, no calendar event will be created. As tasks are completed, they can be marked as complete by clicking the Update button and then clicking Complete. The final page, which we've briefly visited already, is the calendar page. From here, a user can see all of their deadlines as well as add miscellaneous events to the calendar. We can also see that when a task is marked as complete, a check mark will be added to its calendar event. To add an event to the calendar, click Add Event, fill in the details, and click Submit. The new event will appear in purple. To add a longer event to the calendar, simply provide an end date when creating the event. To view a clearer version of the event, a user can click the event on the calendar to open up a modal with the event information. From here, it is also possible to delete events that have been added directly to the calendar. When all of the tasks are complete and the job is finished, the user can navigate back to the job page and click Delete. This will remove the job and all of its tasks from the calendar events. The backend for the application was built primarily using Firebase and its cloud Firestore feature. I decided to use Firebase due to its range of functionality and because it comes with a library for use in React.js. Although I was already familiar with SQL and Postgres, there were a number of features to Firebase that I wanted to make use of, and I wanted to ensure that the application could easily be expanded in the future. Another reason I chose to use Firebase was because it includes a built-in user authentication solution, allowing sign-in options for all of the popular providers such as Google and Facebook. It also provides the tools for implementing it in the front end. This allowed me to build the application knowing that users could sign in and that their information would be secure. Along with the authentication feature, Firebase's Cloud Firestore provided me with a database solution. As I used Firebase to handle all of the back-end functionality, the authentication and the database are already connected, meaning that the data flow is actually quite simple and negated the need to deploy my own back-end server. When deciding about the front end, I wanted the app to be usable on any device, and I needed it to be able to display the data from my database. For this reason, I chose to work with ReactJS, as I was already familiar with it, and it is a powerful tool for creating progressive web apps. On top of React, I used the Firebase tools package to query my database, along with a very useful package called React-Firebase-Hooks, which uses React hooks to set up a snapshot listener and re-render the app whenever the snapshot is updated. This allowed me to create snapshot listeners for all of the different documents and collections within the individual components, meaning that all information displayed within the app is a real-time representation of the database. I also made use of two key packages, the first being Material UI, which I used to create some components such as the burger menu for mobile users and the loading spinner used in various places. For the calendar feature, I wanted the user to have more control over the length of events beyond just job deadlines. Due to this, I needed a solution for displaying events that could span multiple days and be able to be populated by information that can be stored in a database. I chose a package called Full Calendar, which provided all of the functionality that I required for the app's calendar feature, using a simple array of event objects to populate. For the RSS reader, I made use of an NPM package called RSS Parser, which uses HTTP requests to fetch an RSS feed and then parses it into a JavaScript object. There were a few challenges during this project. The first of these was the fact that due to circumstances caused by the national lockdown, I was doing my project alone. This meant that I needed to stay very organised throughout the length of the project in order to stay on top of everything that needed to be done, as I would be the one that needed to do all of it. To achieve this, I utilised agile methodologies. Although I was not working with a team, I was still able to have a stand-up every morning with a tutor, and kept a Kanban board to keep track of all my tasks. I also made sure to maintain proper control when using GitHub, creating a new branch each time I made a new component, and then using pull requests to merge to the dev branch. The next challenges were both related to Firebase. The first was that I had no experience of using a NoSQL database. The second was that the way I had planned to implement the creation of user accounts was using Firebase Cloud Functions, which are effectively server-side event listeners that could be used to create a document in the database if a new user creation event was triggered. Upon coming to implement this feature, I discovered that it required billing to be active on the project, so I needed a new way to create a document for a new user. To solve these problems, I spiked Firebase, making use of Firebase tools and the React-Firebase-Hooks library to try retrieving different things from my database. I discovered that it was possible to check if a document existed from the front end and then create one if it did not exist. This allowed me to bypass using cloud functions completely with very little complication. Firebase Authentication also keeps a list of users that have logged into the app and assigns them a unique ID, which is always the same. Even if an account was deleted, if the same user was to log in again and a new account was created for them, their user ID would be the same as it was the first time around. There are a few UX improvements that I would like to make to the app in the future, such as allowing the user to edit jobs. Due to the time constraints, I had to prioritize the most important features, but this could be easily implemented using existing reusable components. On top of that, I would also like to expand the app with a workgroups feature. This would allow users to create what would effectively be a shared account, mirroring all of the functionality an individual has currently, but shared between multiple users. Due to the fact that the app already displays real-time information in every component, any update made by one member of the workgroup would be instantly visible to the other members. The addition of these features would bring the app closer to being a one-stop shop solution for work organisation. Thank you for listening, and I am happy to answer any questions.